All right, for 799, let's talk about how we can work through this. So Jamal was working on his homework. He had a brilliant realization. He was drawing a triangle in a unit circle to estimate the sine of pi over 10 when he realized that this triangle is the same kind of triangle that he draws when he wants to find the slope of a line. So how can we express the slope of the radius in terms of sine and cosine? So we need to remember that what we're looking at on the unit circle is the x-coordinate of that point. So here's our radius. We're finding the slope of the radius here. The x-coordinate, or the amount we move left and right, that's representing cosine. So cosine of pi over 10 would represent this horizontal movement here from the origin, from right here, okay? And then the vertical movement is represented by the sine of pi over 10. So this vertical movement is represented by the sine of pi over 10. So if you remember back to slope triangles, to find the slope of r, which is our radius, we're going to do rise over run. So I would write the rise of the line or the segment over the run of the segment. Well, that ends up being, based on our triangle, the sine of pi over 10 divided by the cosine of pi over 10. Part B asks, is there any other way you can use a trig ratio to represent the slope? So let's think about this. Let's just say I have some random angle and we'll call it just theta, okay? So this angle that I've drawn in my unit circle is just theta. Okay. I'll draw my triangle in here just like I have been. So I've got my vertical movement. I've got my horizontal movement. If I look at that particular angle theta and I look at this right triangle, I can also label, let's do two things here. I can call this the sine of theta, right? Just like we did above, and the cosine of theta. And we just set up above that the slope of the tangent line, so the slope of r, we could write as the sine of theta over the cosine of theta. All right, now I want you to also think of it this way. What if instead of calling that sine and cosine, what if I just thought about that angle and how I would label the sides in a right triangle? So across from theta, we would call that our opposite side. And adjacent to theta is our adjacent side. Now, we have a ratio that we can use for the opposite over the adjacent. And those are representing the sine and cosine, just like we wrote a moment ago. Those two things are both representing tangent of theta, because tangent is the opposite over adjacent, and because opposite and adjacent are also known as sine and cosine in this situation, then we can call tangent sine over cosine, and that's what our focus is going to be today.